video is for the quadratic equation word problems. So what we're covering today is making or creating quadratic equations from word problems and how we can use those to solve real world problems. So the first one that we have is about area, and it's going to be the area of a rectangle. So the rectangle below has an area of 96 square units. Find the length and the width of the rectangle. So step one, we need to model the area of the rectangle using the given dimensions and the area. So we know that area of a rectangle equals length times width. So if I swap out the area for the information they gave us, the 96, the area is going to equal, so the length here is 2x, and the width is x minus 2. And so remember, anytime that we're swapping out in formulas, we put that information in parentheses, and that just keeps the order of operations intact for us. So step two is to simplify the equation you created and transform it to standard form. So the first thing that we need to do is we need to multiply these two pieces out. We need to multiply 2x times x minus 2. And so this is just using the distribution property. So 2x times x is 2x squared. 2x times a negative 2 is negative 4x. And so if that's equal to, we can put this 96 over here, we can rearrange these pieces. We can subtract 96 from both sides. And we can rewrite this equation now as 2x squared minus 4x minus 96, and then I can set that equal to 0. So in this setup here, when I would subtract the 96 from both sides, the 0 would be over here. And so remember, you can just completely flip an equation like that. As long as all the signs stay the same, you can just turn it around. That's fine. All right, step 3 is to solve the quadratic equation you have created. So I have a feeling that our fallback method is going to be the quadratic formula. So quadratic formula again is negative b plus or minus the square root of b squared minus 4ac divided by 2a. Okay, so using our formula, b is a negative 4, so we have negative, and then b is a negative 4, plus or minus, and then negative 4 squared minus 4. A is a 2, c is a negative 96, and we're going to divide that by 2 times a. All right, so negative 4 is going to simplify to just a 4. And then we're going to do just what's underneath that radical. So we've got negative 4 squared minus 4 times 2 times negative 96, and we get 784. And then 2 times 2 is a 4. So now we're going to do the square root of 74. Let's see if it's a perfect square. It is. We love it when they're perfect squares. So 4 plus or minus 28 divided by 4. And then I can just type that as a fraction in my calculator and let the calculator do all the simplification for me. So I get an x equals an 8. And then I have to go back up and do this one again, remember, because it's a plus minus sign in between that 4 and that 28. Minus, and x equals negative 6. Okay, so x equals 8, x equals negative 6. It says use the solution that is reasonable to the problem situation to find the length and the width. So what we're going to do is we're going to use the 8. So when we're dealing with real world problems, we don't want to use the negative, sorry guys, hang on for me, because the measurements and distance, so I'm going to put a little note here, measurements and distance cannot be negative. Okay, so if I use that negative 6 and I multiply that by 2, that would give me the length of a negative 12. You'll never see a measurement that's a negative number in a real world problem. So that's why we're going to use 8 here. All right, so we're going to plug this 8 in for the x. So if the length is 2x, I would do 2 times 8 for the length, and it's going to be 16. The width is x minus 2, so I would do 8 minus 2, and that's going to give me a 6. And if I go back, so remember, our area was 96, and area is length times width, and so I can check my work and do 16 times 6 and make sure that I get the area that I need. Okay. All right, the next one is for dimensions, and these are honestly probably some of the trickiest ones. These still mess with me. I really have to think about what I'm doing when I work these problems. So Dawson is building a rectangular picture frame. The outer dimensions of the frame are 18 inches by 14 inches. So I've got a picture down here that we can use and draw on. So the outer dimensions of the frame here are 18 and then by 14. Okay? The area of the picture that Dawson is building the frame for is 221 square inches. So here's the little picture inside of the frame, and we know that the area is 221 inches squared. Assuming the width of the frame is equal in all dimensions, find the width of the frame and justify your answer. So what it's saying is that this distance here and then this distance, from here to here is the same. So we don't know what the width is. We're going to put an X there because we don't know what that distance is. Okay? So here's what we do know. We know that the width here, so this is the width of the frame. I know it's a weird word because we use, length times width, but the thickness, we can say the thickness, is an X. So what we need to find, and we know the area of the picture, we know that's 221 inches squared. What we need to find, sorry it froze on me guys, we need to find the length and the width of the picture, and we can do that because we know this information, okay? So this distance here, the width of this picture, if all the way across is 18, and we know from here to here is X, and from here to here is X, we can write, that's the length, 18, and we could write minus this X, whatever that X is. Maybe it's an inch. But to simplify that, we could do 18 minus 2X. That's the distance here. And so we can do the width of this picture the same way. We know all the way across is 14. And we know from here to here is X, and from here to here is X. So we could take that full 14 inches and subtract X twice, which is just 14 minus 2X. And so that is the 14 minus 2X. That's the width of the picture. And so for me, I have to draw a picture. That's the only way that I can do this. I have to see what I'm looking at. So we know that the area of a rectangle, because remember, we're finding the dimensions of this picture. So we know that the area of that picture is 221 inches squared. And then we know that we can multiply the length and the width together to get that answer. So we can do 18 minus 2x and 14 minus 2x. And then we can simplify that. We can simplify that down. So let me flip this. So we can do 18 minus 2x times 14 minus 2x. Okay? So this is the FOIL method. Okay? Or you can still use the distributing if you distribute. Distribute the 18 to everything in the other set of parentheses, and then distribute the negative 2x to everything. So you can use either method. I was taught using the FOIL. It is so ingrained in my head that that is all that I know how to do. So the first numbers are 18 and 14. 18 times 14. So that's 252. All right, outside. 18 times negative 2x. So 18 times negative 2 is negative 36x. Inside, negative 2 times 14, or negative 2x times 14, I apologize. So negative 28x. So remember, if you're multiplying by something with an x, don't forget to go back and tack that on after you multiply the coefficients. And then we've got negative 2x times negative 2x, which is negative 2 times negative 2, which is a positive 4, but x times x is an x squared. So if I simplify this down here, I've got 252. Negative 36x plus negative 28x is negative 64x plus 4x squared. I'm going to just flip the pieces around, okay? So this is still 221. I'm going to write the 4x squared plus, I want it in standard form. Then I'm going to write the negative 64x, and then this is a positive 252, okay? So now we need to solve the equation and choose the solution that is reasonable. So first what I want to do is set this thing equal to 0. So 4x squared minus 64x. I'm going to subtract 221 from both sides. So 252 minus 221 is a positive 31. Okay. So if we solve this thing, so negative b plus or minus the square root of b squared minus 4 times a times c divided by 2a. So negative 64 is a positive. All right, negative 64 squared minus 4. 4 times 4 times 31 gives me the square root of 3,600. 2 times 4 is 8. All right, 3,600. Let's see. Square root 3,600, and we get 60. Okay, we love nice pretties. And typically on these, they're nice pretties. Okay, now this one does involve a decimal. So if we do 64 plus 60 divided by 8, we get 31 over 2, or minus. We get 1/2. So we have to pick the measurement that is reasonable here. And so the reasonable solution is actually the 1/2. And the reason why is 15.5, which is what this is, 15.5. Let's look at it in terms of that. If x equals 15.5, let's look at our picture. That means that the distance from here to here is 15.5 inches, or the distance from here to here is 15.5 inches. That's bigger than the total width of this frame. Okay, so there's no way that this could be 15.5 inches if my total is only 14. So my x value here, the only one that works, is the x equals 1/2. So I'm going to go ahead and write the other one. It's 31 over 2, or 15.5. This is one of those rare situations where you might want to convert it to a decimal, again, to check the reasonableness of the answer. All right, our last type of problem involves consecutive numbers. And these questions come up occasionally, but it's good to know how to work them. So the product of two consecutive negative integers is 1,122. What are the numbers? So step one, consecutive integers are 1 unit apart. So we're going to model those two numbers. So if my first number is x, my next number has to be x plus 1. So if this is 2, 2 plus 1 is 3. 2 and 3 are consecutive numbers. They're in order. Okay? So we're going to create an equation setting the product of these two integers equal to 1122. So we know that the product x times x plus 1 equals 1122. Okay, we're going to simplify the equation. I'm just going to do it quickly so this video doesn't go too long. X times x is x squared. X times 1 is a positive x. And so that would be equal to 1122, but I'm going to move it so my formula is in standard form there. Now we're going to solve this quadratic. Okay, here we go. Negative b, b is a 1, plus or minus the square root of b squared minus 4 times a times c divided by 2a. So we've got a negative 1 plus or minus. All right, let's see what we get on this one. All right, second square root. Oh, no, stop. All right, What's under the radical? Sorry, guys. Minus 4 times 1 times negative 11/22. All right, I get 4489 over 2. So let's check the square root of 4489. 67. So we got negative 1 plus or minus 67 over 2. Negative 1 plus 67 over 2. So my answers are 33. And then if we go back up here, subtraction, and we get x equals negative 34. Okay, so those are our solutions. X equals 33, x equals negative 34. So we have to use the solution that is reasonable. So look at the problem in a situation like this. We want consecutive negative integers. So we know that this is the value we're going to use, this negative 34. Okay, that's the one we want. Then, to find our other value, x plus 1, negative 34 plus 1 gives me a negative 33. And again, that product should be 11/22 when I multiply those two numbers together. So negative 34 times negative 33 gives me a positive 11/22.